In this video, we want to look at controlling the movement of this adjusting screw and then all the guide and that top jaw. So to do that, what we want to do, and this has all been constrained, and I used constraints with mates on all this, but what we want to do is we want to make sure that this piece right here doesn't hit up in this area on this arc part of the fork. And by the way, I have grounded the fork for that matter. Now, what the couple key things here, we want to make sure that when we do this, we get this guide above this flat surface right here, so that when we do our tangent, there are two solutions. It can be either tangent up on the top quadrant or the bottom quadrant. So we need to get that up there on that top quadrant. So to do that, to show where the top of that's going to be, we're going to do a regular constraint, and we're going to do tangent. And we're going to make that tangent to this surface right here. And then finally, this one of these lines on this guide. And we just need the line. And we'll hit OK. And you can see then that is right up against the edge. Now, and it won't move. Now, the only reason we set that up like that is so that we can see what the measurement is from this edge of the screw up to this location here, because originally that's where we set up our cylindrical joint. So if we look at that, there's the cylindrical joint right there, and we have to adjust that. So we'll do an inspect, and we'll measure the distance, and we'll go from there up to there. Let's see, we're getting, that's a conflict of what we're trying to get. So let's see, and if we want, what we can do is we can take those two guides and hide the visibility on those so that we can go in there and measure the distance then from this face to that face. And you'll see there's the number. Now that's kind of a screwy number, so we'll highlight that and do a Control C. Okay, and then we'll go back to that cylindrical location, edit the dimension, or edit the joint, excuse me. And the start location, whoops, I'm sorry, not angular, it's linear. And it's already given there, but we're going to highlight that and do a Control V. That's the actual number right there. And for now then, we're going to make this this value just a -1. And we'll see that we get some movement here. Let's see, we've got, oh, I guess did I go the wrong way? I've got something locked. Something must be locked. Oh, well, duh. The tangent here, I've got to delete that tangent. So that now that can move down. Well, now that's not good. Let's go back and check our limits. Oh, that should have been a negative value, sorry. Okay, and now we can go. So it'll go up to there and there. That positive value is allowing it to get up in the part. That's why that was moving. Okay, so that takes care of one end of it. And we'll get these back. Actually, we really don't need those turned on at this point, because what we've got to be concerned with now is getting the distance for this. So actually, I'm going to change that cylindrical, edit that limit to, instead of 1, let's make that 2, so that it will go down and get at least close to crashing. So if we really wanted to see what that value would be there, let's see, how's that gonna work? Well, let's hide the base again. And if we look straight in on this, we'd be looking at the top view, looks like. Now what the question is, what's going to hit first? Well, let's edit this so that, let's make that 2.5 so that we can at least get beyond that. And you can see that the first thing that would hit would be this plane and that line, wouldn't it? So well, there's 2.5, but we want to make that, we're going to set that back to 2. And that's as far as it'll go right now. So then we can measure, and probably close enough would be if we measure the distance from that point right there to that point right there. And then that's a delta Z, and that's 167. So 2.167 should be our limit then. So let's edit that and get our limit there and make that 2.167. And then we should be able to see that that'll move down until it just does get to that point. So then if we bring the those two guides back, okay, and now that might bring up another point. Well, look, we are hitting right there. So we're going to have to bring that back up, and it's actually going to hit there before it hits the jaw. So let's go back to 2 inches. And 2 inches just gives us a base to measure from. It's basically what we're doing there. Okay, so 2 inches as far as it'll move. So now we need to measure from here to there. So let's measure from this point to that line. And again, delta Z, 105. So 2.105. Should take care of that, and then that'll make that so that it goes just to the bottom there. Now then the other question is, well, what about the base? Is the base going to create a problem for us on that? Let's turn the base back on. I don't think there's any interferences there. So that goes down, and now that looks like it crashes, but again, it's pretty far away from it. So there you can see it. So there's no interferences otherwise. Okay, and that's as far as it goes. So that's how we would go about setting, or at least how I would go about setting up this movement on that portion of the part. And then this, of course, goes in like so. Now I had to change that. I'd lost something there, and I changed that to 90 on that angle, and that's just a little too much. So let's go back and look at that clamp and the rotation on that. And originally I think I had that at about 99. Let's see what that does. So that looks a little more realistic. Okay. So this thing is starting to come together as far as making motions that, and I had grounded the pipe vise fork. So this thing actually will make motions like it really should make. So I just wanted to give you that.